In this video, based on the information given to us, we will attempt to sketch the graph of the function. Now, in this question, the left-hand limit is given at 1 for the function is 3. The right-hand limit for the function at 1 is 7. In this situation, is it possible for the limit to exist at 1? Explain. Now let's sketch the graph. I mean, the answer is not like there are more than one graph possible for the given information, but let's look at one of the possibilities. Now the limit is discussed at 1, so as x approaches 1 from the left and from the 1 from the right is discussed. The left hand limit is 3, so that means as x approaches 1 from the left, the y value approaches 3, and the limit is always represented by an open circle. So the graph, the left hand limit at 1 is 3. So the graph could be like this, or could go down like this, or could go up like that. There are several possibilities. You can pick any one of them. The right hand limit for the function at 1 is 7. So that means as x approaches 1 from the right, the y value approaches 7. So this is 4, 5, 6, and a 7. You see that again the limit is represented by an open circle. So you will have an open circle at 1 and 7. And the graph could have been like this, because as x is approaching from the right, the graph should be approaching 7 from the right as well. So the graph could be aligned like this, or going up, down like this, or going up like that. There is more than one way to represent this information on the graph. Now you can see that the left hand limit is not equal to the right hand limit at 1. Hence the limit does not exist for the function at 1. The function, the function value is not prescribed at 1, hence we cannot graph the function value. So let's see some more examples involving this kind of concept. Now in this problem here we want to sketch the graph of the function where this information is provided, and here you see that the left hand limit for the function is 2, the right hand limit is for the function is -2. You can see that the left hand limit is not equal to the right hand limit. That means the limit does not exist at 2, and f1 is equal to 2. This is the function value. So this is represented by the solid. It's represented by the solid. This is left hand limit is represented by the open circle, and right hand limit is also represented by open circle. Now let's go ahead and graph the information given here. So the the left hand limit is 2. So as x approaches 1 from the left, the y value approaches 2. So one of the possibilities is you could have a graph like that. And the right hand limit for the function is -2. So that means the y value is -2. So one of the possibilities is like this. And the function value at 1 is 2. So that means that x equals 1, the y value is 2, so that means this is a solid. So this is one of the several possibilities to, this graph represents one of the several possibilities for this information here. I hope this concept is clear. Now let's move on to a different problem, and let's try to sketch the graph of this function. Here again you see that the left hand limit for the function is 0. So that means this is the left hand limit is represented, the limit is always represented by an open circle. The right hand limit is +1. Again right hand limit is represented by the open circle, and this is the function value. The function value at 1 is equal to 1. That means this is represented by a solid. Now I just want to recall the viewers that this is a left hand limit because the superscript is negative here, and this is a right hand limit because the superscript is positive here. You can see that the left hand limit is not equal to the right hand limit. the left hand limit is 0, the right hand limit is 1, they are not equal. So we can obviously make a conclusion that the limit of the function does not exist at 1. I mean, it's not, that's not what they asked in the problem. The problem was to sketch the graph of the function, but here is some information that we can quickly conclude, and hence I made that conclusion. Let's go ahead and sketch the graph of this function. So now, again, there are many possibilities. I'm only sketching one of the possibilities. The left-hand limit is 0. That means at 1 is 0. So as x approaches 1 from the left, you get a 0. So that's an open circle. And the right hand limit is 1. So as x approaches 1 from the right, the y value is approaching 1. So that's an open circle again. Here you could have drawn like that. So now the function value is 1. So that means as x equals 1, the y value equals 1. So that's how this graph looks like. So this is one of the several possibilities, one of the several possible ways in which you can sketch this information. I hope this is clear to the viewers, and let's go ahead and watch one more example, a few more, like let's say 2 more examples involving the same kind of concept. Here you can see that this is a left hand limit, and the left hand limit is 2, and that's represented by open circle. And here obviously this is a right hand limit, and the right hand limit is also represented by open circle. And you can see that the left hand limit is equal to the right hand limit in this case. So you have left hand limit is equal to the right hand limit, and hence the limit will exist. In fact, the limit at 1 would be equal to 2. Because they both left hand limit and right hand limit are equal, and hence the limit will also exist, and the limit value will be 2. And the function, this is a function value here. Again, function value is represented by the ordered pair when x is 1, y is 2, and is represented by a solid. Now there are again several possibilities to sketch the graph satisfying this information, but let's just go with one of the possibilities. Here you can see that the left hand limit is 2, so you have one of the possibilities, a graph like that. The right hand limit is also 2. That means one of the possibilities is like that. So as x approaches 1 and from the left and from the right, you can see that the y value is approaching positive 2, and the function value is 2. So this is where it fits in. So this this is an example of continuous function, and we will talk about this in the future videos. Yeah, that's pretty much about it. So this is one of the possibilities, one of the possible graphs satisfying these conditions given here. Now let's go ahead and graph one more example. Here the left hand limit is 2, and we are going to represent the left hand limit with an open circle here. And the right hand limit of the function is also 2 at 1, so that's also represented by the open circle here. But the function value is 3. That means it's represented by a solid, and it can be represented by an ordered pair 1, 3. You can see that the left hand limit is equal to the right hand limit here. The left hand limit is equal to the right hand limit here. So we want to the limit exists. In fact, the limit is going to be 2, because of, these two are equal. So obviously the limit would exist, and it would equal 2. Now let's go ahead and represent one of the possible graphs of this information. Again, there are several possibilities. There are several ways in which you can represent this information using graphs. So the left hand limit is 2, so that means here you have, this is one of the possibilities, and the right hand limit is also 2. You can see that. So as x approaches 1 from the right and from the left, the y value is approaching 2, and the function value is 3, so that means you have a solid here. So you can see that limit is not equal to the function value here. Limit is not equal to function value. They did not ask us, but I'm just this question did not ask us, but I'm just trying to say more about it, because we are right there, and it will be useful in the future as well. Limit is not equal to the function value, hence this function is not continuous continuous at 1. I mean, the function is continuous at every other point, but the function is not continuous at 1. Now here the function is continuous function on the entire domain D, because I mean, you know, the limit is equal to the function value at 1. So you have a continuous function. Here limit is not equal to the function value, hence you have a discontinuous function. I hope you have I hope you are able to now sketch the graph of the function based on the information given to you, and also you have also notice that the left hand limit and the right limit and the limits are represented by open circles. The function value is represented by the solid, and I mean, it was not required, but we just went ahead and discussed when the limit is equal to the function value, you get a continuous function at that point. When the limit is not equal to the function value, you get a discontinuous function at the point at that point. I hope this is clear, and if you have any questions, please write to me in the comments below.